Welcome back. This is lesson 6 of Machine Learning Zoomcamp session 10. And in this lesson, we will deploy a simple application to a Kubernetes cluster. In this lesson, actually, we want to use the simple ping application from session 5. Remember, you send a GET request to /ping endpoint and it replies with PONG. So we want to get that application. Remember, we wrote it in Flask and we want to deploy it with Kubernetes. So let me just edit here, create a simple ping application in Flask, and then we will do the rest. We will set up a local Kubernetes cluster, and then we will create a deployment and a service. So remember, in the previous lesson, we talked about the sort of the anatomy of a Kubernetes cluster. We talked about the main concepts there. We talked about pods. So this is a Docker container running on a node, which is a computer in a Kubernetes cluster. And then these pods are grouped in deployments. So we will need to configure a deployment and deploy it to our Kubernetes cluster. And we will also need to configure a service. So we will need to configure these two things in order to deploy an application. And this is exactly what we are going to do in this lesson. So let me create a folder. I'll call it ping. So this is the folder where we will have our ping application. And I'll go now to session 5 deployment, and we have code here. And then we have this file ping.py. So this is the file we want to deploy. So let me copy it. Ping.py. So this is the app. For this app, we need to create a virtual environment with pipenv. Let me do this quickly in this VS Code console. We need to cd to ping and then do pipenv install Flask and gunicorn. I don't think it installed anything. I think the reason for that is because in the parent directory, we have pip file and pip file lock. So what we need to do is we need to create an empty pip file. Touch creates an empty file. Now we have a pip file here in this ping directory, so it will not go up and then try to find the pipenv file there. It should install directly to pip file in this. Yeah, exactly. So this is what is happening right now. It is updating the pip file in this directory, and it also has created a pip file.log. I don't think there is anything new for us. We have Flask, we have Unicorn, Python version is 3.8. So now what we need to do is we need to create a Docker file for this application. For that, I'll again go to the session 5 we had about deployment, and I'll just get Docker file from here. I'll copy it. So, Docker file. And I'll need to edit it a little bit. I'll replace it. So we copy ping, we don't copy model, and because we copied just one file, we can do that. We can remove this list of files and just do copy ping dot at the end. And then here, instead of predict app, we do ping app. So I think that's all we need to do. Let me do docker build -t ping. Now let's specify a tag for this. If we don't specify the tag, it will be latest. So if I do something like this, it will create a Docker image that will be labeled ping with the tag latest. So we actually need to specify a tag. Let's call it version 001. So the reason for that is we will use a local Kubernetes cluster called kind, which we will set up in this lesson, and it doesn't like when we use the latest tag, so it needs a specific tag. So now I'll go to a terminal to run this. It's docker run -it rm, then we call it ping v001, and then yeah, we also need to expose a port, which is 9696 in our case. And then if I go to another terminal and do a curl request to localhost 9696 ping, I get pong as a response. So that's our application. We successfully built the image, we successfully run it. Oh, stop it. Next step, we want to deploy it to Kubernetes. For that, we need to install a couple of things. First, we want to set up a local Kubernetes cluster with kind. Kind is a special tool that allows to set up a local Kubernetes cluster. And then kubectl is a tool for interacting with any Kubernetes cluster. Let's first install kubectl. Actually, don't know how to pronounce it. Some people pronounce it kubectl. Some people pronounce it kubectl. I pronounce it as kubectl because I don't see how this can be read as cutl. Anyways, yeah, so I'll go with kubectl. Yeah, if you know what is the right way of pronouncing it, write in Slack. But yeah, let's install it. So for that, I will go to Google and write kubectl. And then the first thing we see, at least here, install tools for Kubernetes. At least this was the first result for me. Oh, actually, here it mentions kind. We actually will need that. But first, let's install kubectl. By the way, if you're running this on Windows or macOS, you probably use Docker Desktop, and Docker Desktop comes with kubectl already. So at least I have it on my Windows computer. So when I install Docker, it installed kubectl together with Docker. And I think it's doing the same thing on macOS. On Linux, it doesn't do that. So on Linux, you need to install this separately. And let's take a look at how to do this. So what you need to do is you need to download this thing from here. Yeah, actually, what I usually do, because at the end of this session, we will also deploy our application to EKS, which is a Kubernetes cluster from AWS, from Amazon. So that's why I usually install kubectl from AWS. Kubectl AWS. And then there is also an article about that on AWS website. And yeah, so let me enlarge it. So there is also a thing for Linux. So what we need to do is install this thing here. So let me copy it. Let me go back to my bin directory that I created 2 lessons ago. So in this directory, I already have Docker Compose. So what I want to do now is I want to download kubectl here. So then it will be downloaded to the bin folder, and it will become available on my path variable. So when I write kubectl, my terminal will recognize what to do with this command. So let me just copy this. So now it's downloading it. So yeah, it uses curl instead of wget. Okay, I have it here. Now I need to make it executable. So for that, I do change mode +X. Okay, now it is executable. So let me go back and test that it works. So it does work. Remember, I said that we need to install 2 things. We need to install kubectl, and we need to install kind, which is a tool for setting up a local Kubernetes cluster. And I write kind Kubernetes. And then what I have in my results is this quick start. So this is what you need. This is the address. And yeah, so there is installation, like how you need to install it. So there are instructions for macOS, Windows as well. Actually, I have no idea what is this chocolate tea. Sounds yummy, but I have no idea what is. Like, I guess this is some sort of Windows package manager. I was able to test this on Windows using this thing here. So there are binaries for Windows. So on Windows, I was able to also test this. It also works if you have Docker installed. So, but I'm on Linux right now. So let me copy this thing. It actually tells you what you need to do. So I like using wget. So do it the same here. I'm downloading from this location and I'm writing this to kind. Okay, now I have it. Now I do change mode +X kind. So let's go back to the location where we were before. So this is our location. So we installed kubectl, we installed kind. So now what we need to do is create a cluster. To create a Kubernetes cluster, what we need to do is kind create cluster. So let me copy it. And now it's creating a cluster with a name kind. It will take a bit of time. I think now it's downloading images for kind. So the first run takes a bit longer, but then the next time you create a cluster, it's faster because you already have these images in your Docker cache. It took a bit more time than I thought it would, and probably next time I run it, it's much faster. But now what we need to do is we need to configure our kubectl to know that it needs to access this kind -kind cluster. Let me just paste this command. And then, yeah, it's saying some things. But what we can do now is we can check that things work. So for that, we do kubectl get service. So it will list all the services that are running in our Kubernetes cluster. Because we haven't deployed any service ourselves, all we have here is a service called Kubernetes. And if we do get pod, we don't have any pods. And if we do get deployment, we don't have any deployments. Since these commands work, it means that we successfully installed kubectl and we successfully installed kind. And now we have a Kubernetes cluster. I think if I do docker ps now, we have now this kind control plane. So it actually, what kind does, it uses Docker to create a Kubernetes cluster. The way it's implemented, it just runs Docker things. And for us, it feels like we're interacting with a real Kubernetes cluster. So it's quite useful for testing things locally. Okay, so now we installed kubectl, we installed a local Kubernetes cluster. So now what we want to do is create a deployment and create a service. So I'm here. So actually, like you will see later that creating this deployment and creating services, it's quite a lot of configuration. So we will need to write a lot of YAML file. YAML is like a special format mainly for configuration. So for this reason, I want to install an extension in Visual Studio Code for Kubernetes. You don't have to do that. You also don't have to use Visual Studio Code for that. But for me, it will make it easier to create configuration. It has some sort of templates, but for you, you can just see what I created, type in your favorite editor. So you don't have to do this, but I will now install it, Kubernetes. So the first one from Microsoft. So let me install it. So now I have this extension, and yeah, let me go back to this folder. And what I will do now is first I create a deployment. In deployment, we specify how the pods in the deployment will look like. And then after that, we will create a service. Let's start with the deployment. So I'll call it deployment.yaml. And then now if I want to create a deployment, a Kubernetes deployment, I just start writing deployment, and the extension I just installed suggests to use a template. So I hit enter, and then I get this huge file. You probably can see now why I wanted to use an extension instead of typing all that. That's just a lot of things. It's 22 lines. I didn't want to type that. This is how a YAML file looks like for the deployment. So there are quite a few things. You see this my app. This is the name of the application, and it's repeated 4 times. Now I need to give it a name. So I'll write it ping. It automatically write pings in all these 4 places. The first thing that we write here is this kind deployment. We say here that this YAML file is about a deployment. So this contains a description of a deployment. Then we have a bunch of things, all have the same name. So let me explain what's going on here. The first one, this thing, this is the name of the deployment. And the last thing here is the name of the pod. They are usually the same. So now I will execute this, and you will see this when we use kubectl to actually see what kind of Kubernetes resources we created. So let's say if I here write ping pod, I can actually do that. Usually it should be the same. I write ping pod, and then here I'll write ping deployment. So it will create a deployment with a name ping deployment, and this deployment will contain pods that are called ping pod. We'll talk about these 2 things a bit later. So now I want to tell you what the rest of the file is about, what it means. So here, the metadata, we specify the metadata, the name of the deployment, and then we have this thing called template. This template is a template for pods. As you remember, the deployment contains multiple pods. So this template thing is a template for each pod, because all the pods within a deployment are the same. They have the same image and the same config. So this is a template for the pod. And then in this template, we provide the specification for each pod. Each pod has a container. So the name of this container is ping pod. Then the image will be ping v001. So these resources is how much resources we want to give to this pod. Some pods, some applications require more resources. So for example, our TensorFlow serving model will probably require more resources. Some require less resources. So let's say for this one, we give 128 megabytes of RAM. So this is how much CPU we give. This 500M means that we give it 0.5 CPU. So we do not allow this pod to use more than 50% of one CPU. Let me check HTOP. So here I have 2 CPUs on this computer. And when I say that CPU should not be more than 0.5, I am telling it you shouldn't use more than 50% of one CPU. You can say alternatively 500M. So these 2 things are the same. Then the last thing I need to specify here is the port. This is the port on the container that we are exposing. So this is the port that we want others to access. So in our case, this port is 9696. Okay, we discussed the template. And now let's talk about these labels, these two last things. We already talked about this metadata piece. So this is the name of the deployment. We talked about the name of the container. So this will be the name of the pod. Now we have this metadata thing inside the template. What this line is telling us is that each pod will get a label up, and the value for this label is pink. So each pod will get this label. And then this thing here means that all pods that have a label up that is equals to pink, they belong to this deployment. I'm not really sure why we need this. To me, it's kind of clear that if we specify a pod within this deployment, it's kind of clear that they are linked. They should be linked, but in Kubernetes, actually, we need to explicitly link them. So for each pod, we say that this pod has a label up equals to pink. And then for deployment, we say that like this is how you find all the pods that belong to this deployment. And yeah, one last thing is here we can specify replicas. So this is how many pods we want to create. So for this deployment, we want to create one replica. And yeah, it will use this selector to see how many pods are there of this deployment. And if it sees that there are 0 pods, so there is nothing, it will add more pods. And if we later add this and increase this to 10, what will happen is it will say, okay, there is 1, let's add 9 more. Actually, on this computer, I have only 2 CPUs, so I will not have enough resources to have so many replicas. So let's run now with just one replica. We have this deployment. Now we want to apply this deployment. So now we want to take this config file, and now we want to apply this to our Kubernetes cluster. For that, what we do is we use kubectl. We do apply -f. -f means read it from a file, and the file is called deployment.yaml. So now I hit enter, and it says the deployment, ping deployment is created. And now I do kubectl get deployment, and I see that I have a deployment with name ping deployment, and I see the status. I requested 1 pod, 1 replica, but 0 of them are ready. I think there is actually a mistake. So now if we do kubectl get pod, we will see actually it doesn't give it a name. So I thought it would give it a name ping pod. It actually gave it a name ping deployment. I'm not sure then why we need this ping pod. Okay, so the pod we have is ping deployment and then some ID. And then we see status error image pool. When you work with Kubernetes, you will see this status quite often, I think. So let's actually take a look at what's going on. We want to see if Kubernetes wants to tell us anything about that. So for that, we use kubectl and then describe. And then we want to describe a pod with this name. I just copied this name from here and I hit enter. And this is the description. So let me do less so I can see it. Yeah, so we see the description, we see the name of this pod. We also see the labels that we assigned. So the status is pending because it hasn't created it yet. And then container, yeah, so this is the name of the container. We can see it here. This is not the name of the pod, but the name of the container. And state is waiting. The reason is this. And I think if we scroll down, now it will tell us, yeah, so now it's telling us more things. But now, yeah, at the end, we get the error messages. So the error message that we have is failed to pull image ping v001. This image doesn't exist here. That's why it failed. So it couldn't pull the image. And that's why we have this error. So usually you have this error because you cannot pull it. Most of the time there is a typo or you don't have sufficient permissions to get the image. So in our case, what happened is we didn't let kind know that this image should be registered and Kubernetes should know about this image. I think we go to kind's documentation. We should see it somewhere. So loading an image into your cluster. So we already have a bunch of images locally. We now want to load them to the cluster so they become visible. So for that, we do kind kind load, and then we specify the name of the image. So for us, it's ping v001. So that's all we need to do. Oh yeah, right. So load Docker image and then the name of the image, right? Kind load Docker image and then the name. So it says it's not yet present in the cluster. Let's load it. Okay, so now it's loaded. Let's again do kubectl get pod. This deployment, it kept trying to load the image, and at the end it succeeded. So we see that the status is running. So the pod is running. Okay, so now we have a deployment. So the next thing we need to do is we need to create a service, but there is a way that we can test the deployment before creating a service. For that, we can do a thing that is called port forwarding. So we have a Kubernetes cluster. It's a small cluster with just one node. And on this cluster, we have a pod, pink, and then, yeah, it lives in this deployment. And then we have our laptop here. So what we have on our laptop is we have our kubectl. We have a port 9696 here. So using kubectl, we can connect this port from this port to a port on our computer. Let's say we connect it to a port 9696 here as well. And then we can access this port by using localhost. This thing is called port forwarding. And we can use kubectl for doing this. It's kubectl, then port forward, and then the name. Let me do kubectl get pod first. So we have a list of pods. And then I do kubectl port forward. Then I need the name of the pod. So this is the name of the pod. And then I need to specify, I think it's again the name of the port on my laptop, on my host machine, and then the port on the pod. Now it is forwarding my port on the host machine to the port on the deployment. And now I'll go to another terminal, and now I will do curl localhost 9696/ping, and then I get ponk as the response. And this response is actually coming from the pod we just deployed with Kubernetes. We can see here, it adds something to the log. It says handling connection for 9696. So if I do a bunch of line breaks here. So now let me execute it one more time. And we see that it created another line saying handling connection for 9696. So there was a request. It forwarded this request to the pod, and then the pod processed this request and sent the response back to our computer. Okay, let me stop that. I think now if we try to do this thing once more, yeah, so now it says fails to connect to local host. Connection refused because there is nothing running on this port. Okay, so we created a deployment. Now we need to create a service for this deployment. So I'll call it service.yaml. And then again, here I just write service and it pre-fills everything for us. So there are two things that we need to fill. So I'll write pink, and then here it's also pink. So it's just two names here. This one is the name of the service. And this thing selector, it uses to understand to which pods it needs to forward the requests. So it needs to know when it gets a request, which of the pods can receive it. And it looks at the selector, the app tag, and it looks for those pods that have app tag set to pink. This is exactly what we do here. So here in our template for pods, we specified the label. The label app for the pod should be pink. Now, using this information, the service, let's say this one, it knows which pods it needs to forward the request to. Okay, then we need to fill in two more things. So the port, so there are two ports. So target port, let's start with the target port. This is the port on the pod. So the port on the pod is 9696. Remember, we specified it here. So this is the container port, the port that container exposes. So this is the target port. And then this port is the port in the service. So let's say in the service, it can be the port 80. The port 80 is like the default HTTP port. It will get requests. It will listen for the requests on port 80, and all the requests it will get, it will route to one of the pods to the port 9696. You can draw it here. So we will have a service. The service will have a port 80, and it will forward all the requests to this port 9696. And we as users will actually communicate with this service. So we will send our request to this port 80 of the service, and then the service will decide to which port to forward the request. That's actually all we needed to specify here to configure. So now let's do kubectl apply again. Kubectl apply -f, then service. So now it says service ping is created. Now I do kubectl get service, and then I see there's a service, Kubernetes service, and then there is a ping service. You can also do kubectl get svc. This is the same as service, it's just shorter. Many of my colleagues do svc, and first for me, I was trying to figure out what this svc means. So yeah, if you see something like this, it means service. So we have two services. One service is ping, and the other service is Kubernetes. And then the type for the ping service is cluster IP. Remember, we talked about two types of services: external services like this one, and internal services. Cluster IP is an internal service, and external service is load balancer. Since we use kind, which is a local Kubernetes cluster, it doesn't really matter here what kind of type of the service we use, but when we use a real Kubernetes cluster, it actually matters whether something exposed outside of Kubernetes or not. And I think here we need to specify type, and then there are multiple options: cluster IP, external name, load balancer, node port. I'm not sure what these two mean. I usually just use either default one, cluster IP, or load balancer, which is the external one. So let's now change the type of the service to load balancer for ping, and we do kubectl apply again. So it says it's configured. The previous one was created, but now it's configured, so it's updated. Now we do kubectl get service again. Here we have this cluster IP, and we have external IP. For the cluster IP, external IP is none, because this is an internal service. But for load balancer external IP, there should be an external IP, but it will not appear here because we use a local Kubernetes cluster. We haven't configured it to be able to get an external IP. So it will be pending for forever unless we configure something. So it will always be pending. And let's say if we use EKS or some other Kubernetes in cloud from any cloud provider, then Kubernetes clusters there usually will assign an external API or external name to our load balancer service. Okay, so what we can do now is we can do the same trick we did previously. So when we did the port forwarding to the node, now we can do the same port forwarding, but for the service. We do not have external IP here. We cannot directly access it. What we can do is we can just do port forwarding and pretend that we're connected to an external service. Let's do this kubectl port forward, and then we need to write service/ping. And then again, we have the same format. So first we need to specify the port on the host machine. I will not be able to map it to port 80. It will complain about permissions. I think I will need to use sudo for that. So I will map the port 8080 that I have on my computer on the host machine to the port 80 in the service. So let me run that. Actually, you see that it's forwarding to port 9696 because this is what our service is doing. So it's forwarding things from port 80 to port 9696. And this is still failing. So let me replace it with a port 8080. And now we get the response. And we see this in the logs. And what happens is instead of doing port forwarding to the pod directly, we are forwarding it from the service. Okay, let me stop it. So actually, that's all I wanted to cover in this lesson. In this lesson, what we did is we created a simple application that when you send a GET request to ping, it replies with PONG. Then we deploy it with Kubernetes. For that, we installed kubectl, which is a tool for communicating with any Kubernetes cluster. And we installed kind, which is a local Kubernetes cluster that we can set up anywhere where we have Docker. Then we created a cluster with kind, and we configured kubectl to communicate with this kind cluster. And then we created a deployment of this ping application. And then we created a service. And because this thing is running locally, we used port forwarding to test if it's working. Yeah, that's it for this lesson. And by the way, if you know how to get this thing working, if you know how to get kind to map to external IP, please let us know. Please write in Slack. I'm curious about that. I just didn't have a chance to figure this out, how it works. I think, yeah, if we go to this kind documentation load balancer, it kind of tells you what to do. I just never went through these instructions and never figured out how to actually use this. But yeah, maybe if you want, you can try doing that. But that's it for this lesson. And in the next lesson, what we will do is we will deploy the services we have. We will deploy the TensorFlow model, and we will deploy the gateway service to this Kubernetes cluster that we just created. So see you soon.